Hello viewers and my dear students, welcome to session 5 on isometric projection demo. These are all the problems what are done in the main sessions. Under that we have been doing problem number 17 and we have completed already one session on this. This is the second session on problem 17. See here, this was the problem earlier. See here, frustum of square pyramid was sitting on square prism of sides 80 and thickness 20. The top solid was a frustum of square pyramid. That means cut portion of a pyramid. And the bottom solid was a square prism. Okay. Both I have completed here. This is, as you see here, this is square 80 only. That is a square prism of sides 80. You can see, I think it is 80 only. And if you see this is height 20 only. And in the same way, this if you see it is 40 only. You see here, this is 40 only. Okay, if you see this is 20 only. This is 20 only. On height is 60 for this. Okay, now what you have to do here is, this has to be placed centrally over this. For that, you should show the procedure in the exam and all that. Okay, what you do, no? You take the center here. From mid to mid, you draw one center. Mid to mid, you draw one center. Okay. See here. Call this as C0. Okay, call this as C0. Okay. Now you see here, this C0 is the center of the top surface of the square prism of sides 80 and height 20. C0 is this center. Okay. Now this is this. Okay. You can call this also. You see here, this. You see here, let us say C1 is the center of the bottom surface of the frustum of square pyramid. You should see to it, this C1 should match with this C0. Okay. That means the bottom surface center should match with the top surface center. Then only the two solids will be placed one over the other centrally. Okay. Now what I'll do, I'll take a move command. I'll select the entire thing. Okay. Copy is not needed. Okay. This move copy is not needed. You take the center and move with reference to this and place it here. Okay. Now as you know here, once you make it, now you can remove this. Okay, now you understood. Only for understanding purposes, C0 and C1 should match. I have done it. Now it is this also, you can remove it off. Okay, you know very well, this is the isometric projection. Did you follow? Please understand, this is isometric view, because I have not reduced in lengths. All see here, this is 80 means 80, this is 40 means 40, this is 20 means 20 only. In that way, I have not reduced. Okay, but here the visibility. Now the problem is not completed fully. Now you have to complete the visibility of this. Visibility, as I told you in isometric, it is always from top solid, top surface first. Top solid, top surface anyway should be darkened. Left surface and right surface should be darkened. Okay, then come for the bottom solid, top surface. Okay, I'm repeating, it is always visibility in isometric. This is very crucial, because unless you do the visibility properly, it won't look properly. The isometric projection will look odd and you lose marks. That is why, listen to me carefully about the visibility aspects. Visibility is always from top solid, top surface first. This anyway has to be darkened. top surface, top solid. This top surface darkened, left surface should be darkened, right surface should be darkened. Once you do the top surface, top solid completely, then go for the bottom solid. Bottom solid also, first you concentrate on the top surface. Top surface is this. See here, this portion is invisible. That you have to do. For that, anyway, you have the split command here. Split command. You click on this and click at the intersection here. Okay, and again click on this and click at the intersection here. Okay, now as you know here, this back portion, back portion, keeping control button pressed, you make it 0.13. Okay, in that way you are able to complete the isometric view. You see here, this is isometric view. See here, what I'll do. This is no copy also. Okay. Now you see here, I have made this. See here. Now this is also isometric view. This is also isometric view. Since are not reduced in its length. Now let us say I'll take scale command. I'll select this entire thing. Okay. I'll scale factor 0.816 I'll take. Okay. Now as you see here, now as you see here, you have both isometric view and isometric projection here. Okay, this you never forget. Okay, then you show this. Okay, you show this. This is isometric view, this is isometric projection. In that way, you show some of the dimensions at least for the examiners and all that. You see here, I'll before you forget, I'll just see isometric view. This is the isometric view, but this is isometric projection. Okay, see here, this isometric view also is shown, isometric projection also is shown. See carefully, this is actually 80 only. If you see this, because in some of the university they say draw isometric view. When they say isometric view, don't reduce the dimensions and all that. You see here, this is actually 80 only. This is actually 80 only. This is actually 20 only. In case you are finding any difficulty, no, immediately enlarge that. That will be very better. You will definitely get this. Okay. Okay, 20 only. This is 40 only. In that way, it is actual distances. Actual distances, if you have, you call it as isometric view. Now it is isometric projection. No, in isometric projection, you just see what you do here. You see here, this is actually this will be 80 into 0.816. That's why 65 it will be. Okay, this is 80 into 0.816, and this will be, okay, this is 20 into 0.816, that is actually 16. In that way, what you can do, no, these dimensions, you make it blank, okay, and this, even this also, you make it blank, even this also, you make it blank. Then what you know, what you should do is, you see here, what I'll do, ISO 20, ISO 80, ISO 80. In that way, you can do it for more perfection. This is ISO 20. This is ISO 80. This is ISO 80. Okay. And if you want, you show this also here. Sample things. Okay. You know very well. Okay, this also sample thing. Okay, this is actually ISO 20 only. ISO 20. Okay, this is ISO 20. If you do this, this also you do in the same way and call it as ISO 40 in that way. This is this isometric view. This is isometric projection. Views look same. Okay, in order to reduce time, instead of multiplying by 0.816 and all that, okay, we do isometric view so many number of times. In some of the universities, they clearly give isometric view only. When they give isometric view, don't they reduce the dimensions. When they here, when you're using CAD, anyway it is easy. Do this first, take the entire thing, okay, and multiply by 0.816, and directly you get the isometric projection. But earlier when we were doing manually, it used to be difficult. Okay, for everything 80 into 0.816, you used to using calculator. We are taking the revised dimension, even 40 into 0.816 revised dimensions, 20 into 0.816 revised dimensions and all that. It used to be difficult. Now it is no longer difficult because you do everything isometric view only, and then take the entire thing and multiply by 0.816, and you get directly isometric projection, right? Clearly isometric projection. Sample you show. This is ISO 80, ISO 80, ISO 20, ISO 20, ISO 40, and height is ISO 60. In that way, you call this. In that way, isometric view and isometric projection are clearly given the idea for you. Okay. Now you see here, any problem, if there are any problems without sphere, without hemisphere, yeah, you can direct, your job is directly isometric view. Don't reduce dimensions and all that. Okay, directly take isometric view and finally multiply by 0.816. But when hemisphere and sphere is involved, take care because you have to do isometric projection only for that, because the isometric scale and all that will vary. In the next session and all that, we'll take a problem on hemisphere and we'll continue on that. But even here, this also we'll continue on rating orthographic projection in the next session. Okay. Thank you very much for watching. Thank you, viewers. Thank you very much.